In this video, we're going to have a look at what recurrence relations are and periodic sequences. A recurrence relation tells you how to generate the next term in a sequence, given the term you already have. It could be, the sequence could be arithmetic, it could be geometric, it could be something else. Defined mathematically, it looks something like this. So un plus 1 is my next term, un is my current term. And if I apply the function, whatever it is, to my current term, I can work out the next one. Now that might not make a lot of sense, so we're going to have a look at recurrence relations in practice. Have a look at these two questions. It says generate the following sequences, and our first one here is un plus 1 equals un plus 5. Okay. We're given what the first term is. We just need to find the following terms. So u1 equals 2. Right, I now want to work out the next term, u2. So up here, I want to make this subscript 2. That means I need to make n equal to 1. Okay, I'm going to put n equals to 1 into here. So I'm going to get u1 plus 1. Oh, crikey. I'll get that. u1 plus 1 equals u1 plus 5. And we can evaluate 1 plus 1. It's actually u2. Which is useful because u2 is what we're trying to work out, the second term. And we're told to work out this term, you take u1 and add 5. u1 is 2. So u2 is 2 plus 5. Brilliant. And we've got u2. Now let's work out the next term. So I want to work out u3. That means I need to make n equal to 2. Okay, and then our formula says u2 plus 1 equals u2 plus 5. Okay, and u2 plus 1 is actually u3 equals u2 plus 5. Brilliant. And the formula is telling us to work out term 3, you take term 2 and add 5. Term 2 is 7. Plus 5, which equals 12. Alright, and you can see we're generating the terms in this sequence. 2, 7, 12, and you can probably see to get the next term you just keep adding 5. Right, let's have a look at another example. Let's do B. I'll call that A there. Here's B. Okay, so alright, we need to generate the terms in this sequence. We're given the first term, it's 1. It's quite helpful. Alright, I now want to work out u2. That means I need this subscript here to be 2. That means I need n to be 1. So I'm going to put 1 in there as well. Let's have a look at what the formula tells us to do. So n equal to 1. Oops, wrong formula. So we've got 3u1 plus 1. Okay. Alright, and we can evaluate the 1 plus 1. It just gives us 2. Brilliant. Alright, so to work out the second term, you do 3 times the first term plus 1. Right, first term is 1. So what we got? 3 plus 1 is 4. Brilliant. There's our second term. Alright, let's work out the third term. I want to make this here equal to 3. That means n must be 2. I've got to put 2 in there as well. Let n equal 2, u2 plus 1 is 3 times u2 plus 1. The subscript 2 plus 1 actually is 3, so let's write that in. And the formula tells us to work out term 3, you do 3 times term 2 plus 1. Term 2 is 4. So 3 times 4 plus 1. 12, 13. Brilliant. Alright, and you don't have to write all of this out in the exam. To work out the subsequent terms, you can just take that, sub it in for un, and just get the next term. So you do 3 times 13 plus 1, take the answer to that, times it by 3, add 1, take the answer by that, times it by 3 and add 1. And that's what a recurrence relation is.